So what's a proturan? It is a small, unpigmented soil microfauna. Okay, they were discovered in 1907 by a zoologist named Silvestri. Again, I said they were small. They are unpigmented, which means they are usually white or ivory or slash can reflect the color of the soil around them. So occasionally they'll look like little creamish brown blobs running around. They tend to be white if they haven't eaten anything and yellow if they have. They are extremely moisture dependent, like most soil microfauna, and their name means first tail. So, cool. Here's a picture, which I've already posted in my part 1 video, but here you go, again. Okay, what can I tell you morphologically about this creature, because I am so excited when we talk about parts. First bit that I always cover is body plan, okay? With a lot of arthropods and insects. Arthropods, the body plan matters more. Insects is kind of standard, but in these 3 Entomognathia groups, they actually diverge a lot more than they normally would, okay? Oh, I should reference that. I am talking about one of the 3 orders in Entomognathia, and that's why this matters. So, diagram chart thing I made. Okay, so in general, the tagmata, or the body plan, is the 3 standard hexapod body plan, okay? And that the head segment, the thorax, and the abdomen, okay? The head is generally considered 1 segment. The thorax generally has 3 segments. The abdomen can have 9 to 12. Asterisks here, Wikipedia says 8, but most academic sources say 9. So I think what's happening here is there is a discrepancy between people reading the molt differences, and I think someone made a assessment, which, depending on, if you go with the academic literature, everybody says 9, okay? Except for, I think, a couple sources that say 8. But again, it's something weird with the molts. So I did break it down a little bit earlier as we get down there. But I'm going to cover molting separately. Okay, for the head, I'm going to cover the head part first. It is considered what we call conical, which just means it is anteriorly tapered, okay? It is also a microcephalic head, which just means small in proportion to the body. So the head is disproportionately small. For the mouth parts, they have prognathious mouth parts, which means pointing straight forward, okay? Because insect mouth parts can go down, they can curve, but they're this way, okay? So they're pointing out. For the type, it is considered a piercing mouth part. Now that gets a little iffy when I go down to food and diet. So there is some, we're gonna say piercing. Importantly, that they have that gnathial pouch that I talked about way back in the classification video. And this is a simple membranous pouch around the entire mouth parts, okay? Their mouth parts are actually really simple, which is wonderful when talking about insects or hexapoda. They have mandibles, which these are styliform, which just means they're pokey and slender and thin, okay? They do have maxillary palps, and those are 3 segments, okay? And the mandibles and the maxibles are right there, okay? They do have labial palps as well, and those are 1 segmented. The labrum is immobile, which is the top part, okay? That matters. Okay, so when you get into insects, the discussion on the mouth part gets really, really particular. Okay, so if you were to try and do anything, there you go, there's your data. Interestingly, I'm going to post a picture. That is the pseudo-oculi, okay? That is unique to proturans, okay? I believe I did green. Hold on, let me check. Ha, I did green. Okay, so that appears to be a vestigial either antenna or eye remnant, okay? There is a lot of not sureness on that, but it is very specifically conehead, okay? There is some documentation saying not all coneheads have it, but especially with like the electron microscope scans, you can see it. I'm also going to put another picture of it. Although I think that picture has like a whole bunch of things. So it's in there, it's green. So that just covers the head. All right, now we're getting to the thorax, which their thorax is actually somewhat simple. Okay, they have 3 parts, which is simple. Okay, so they have something called the protonotum, the mesonotum, and the metanotum. Okay, so if you look at the pictures, actually, I'll put a picture up again. So the top part, that really thin and weakened part, that's the protonotum. Okay, the next part is the meso, and the next part is the meta. Okay, interestingly, depending on which family of conehead you are looking at, either there is one spiracle, which is a breathing apparatus, or it's basically a hole or their lungs that they pull in air from. There's one, either on the meso or the meta, and that tells you which group they're in, okay? Like all insects, or what defines hexapoda, the legs, okay? There is a leg on each segment, so they get 3 pairs or 6 legs in total, okay? Each leg has 5 segments, which is incredibly small for them, but it's standard for hexapoda. Actually, I shouldn't say it's incredibly small. It's standard, okay? So we got the coxa, we got the, oh, hold on, ready? Trotochanter. Okay, I'm gonna botch that, but that's the next part. The femur, the tibia, the tarsus, and then the pretarsus. Now, there was lots of what we call sensilia or sensi on them, which is just hairs, okay? So that matters. The last part of the legs is a pretarsi. This has a median claw and an empipode, which this is a callback to the crustacean heritage. So this is one of those things where if you did not know about the hoopla between crustaceans and myriapods, you wouldn't know why this matters, but this matters. Okay, so this is one of the basal insects that really supports the crustacean origin. Okay, so there's that. Now we're going to cover the legs real quick. So those first legs, they are enlarged. They are what we call antenniform. They're held upright and basically and front facing and have replaced their antenna. So they use these to sense, and they do not help out in locomotion. The second and third legs are ambulatory or walking legs, and they are rear facing. So the number of segments of this, oh, I already covered that. Oh, no, but there are no abdominal spiracles. I did not cover that. Okay, so, and that no abdominal spiracles is really important because that's what distinguishes them from the rest of hexapoda when it comes to breathing. So there's your thorax. Next video we'll go into abdomen and weird behaviors.